Okay, class. Good afternoon, class, again. So let's start now the lesson. As I've been doing for the past weeks, we always start with the keywords and key phrases. So this lesson is divided into three parts. So part one is the measures of central tendency. So under central tendency, the keywords and key phrases are the mean, median, and mode. So please write them down and leave spaces so that if you want to take down notes, you can take down notes. Okay, now part two is about measures of dispersion or variability. So under this part, we'll tackle about range, standard deviation, and variance. Okay, then again, leave a space so that if you want to take down notes, since we are inside the PowerPoint, you can write the details. Okay, and then the third part is about measures of relative position or location. So under this part, we will tackle about percentiles and quartiles. Though we will also discuss here about box and whisker plots, where this will this represents the three measures of descriptive statistics. As I mentioned, this has to do with descriptive statistics and not inferential. What are the objectives for this module or this lesson? So at the end of this module, you're expected to use a variety of statistical tools to process and manage numerical data. Apply the measures of central tendency, dispersion, and relative position in given certain conditions. Advocate the use of statistical data in making important decisions, particularly in business decisions. So class, so here you have these measures, no? To manage the numerical data. So in particular, we're dealing with numerical data. No? So you'll be dealing with numbers. But here we'll just be presented with just few numbers, not really that large numbers, just few numbers to understand the concepts, these concepts of measures in descriptive statistics, and which will help us to make important decisions, especially in business. Okay. So now, as I mentioned, we'll be dealing with data. Data, so we call them in general the data set. So a data set refers to a collection of numbers or values. So again, numbers, numerical data that relate to a particular subject. So there is a subject, and then this data set related to that subject. So it can be a researcher, no? Or somebody who's in the business and would like to make a decision. So he will collect data to help him or her to arrive at a decision for that subject in the business. For example, these are examples, no, of data set. But if you look at it, there are just few. There's not many. But in reality, there will be a lot. Okay, just for you to understand the concept. So we'll just deal with few data values, data sets. So we have your sample test score students, fish eaten per dolphin. But of course, there's an objective why you have to collect this, and why do you have to collect this data. There must be an objective to help you in decision making. Data management, so that's already included in the objectives. So data management refers to an administrative process by which the required data is acquired, validated, stored, protected, and processed, and by which its accessibility, reliability, and timeliness is ensured to satisfy the needs of the data users. In this module, data sets and how to use the operations of mean, median, and mode to manipulate the data is the one to be discussed. However, if you will look at this, measures of central tendency, but of course, we will use this also, this data management in other measures, like measures of, which I mentioned already at the beginning, measures of variability or dispersion. The other one is the measures of relative position or locations. So we use these measures to manage data. And usually the data users have an objective. If they collect data and then they manage them, and in managing them, they have to measure. They have to apply these measures of central tendency, measures of dispersion, and measures of relative position. They have an objective why they have to do that. Now, but whereas here in this PowerPoint, we only emphasize how to compute them. But I want to put you in the context that they have applications, okay? Even at the beginning, I have already told you that. Now, I think this is the focus of the first measure, the measures of central tendency. So it's a single value that attempts to describe a set of data by identifying the central position within that set of data. So the focus of this measure is the center of the data. That's why it's called central tendency. As the word implies, central, the root word is center. Now, we're after that. And to identify the center, we want to represent it by a value, which we call as which is a single value, but this will be specified later into three. And these three are the mean, median, and mode. Okay. As such, measures of central tendency are sometimes called measures of central location. They're also classed as summary statistics. The mean, often called the average. The average is the most commonly used, right? It's most likely the measure of central tendency that you are the most familiar with, but there are others such as the median and the mode. So as I have mentioned, to describe this center of the data, which we represent by a single value, we use this three. So there are formulas for this three to arrive at a single value. Okay, more. The mean and median and mode are all valid measures of central tendency, but under different conditions, some measures of central tendency become more appropriate to use than others. So it depends. No, it depends on the situation. There are times that mean is the best in this situation, median or maybe the mode in describing the center of the data. So it depends in the situation. It depends on the objective of the users or the researchers. Okay, the mean refers to the sum of the numbers divided by n's. Median, it refers to the middle number if n is odd for a rank order list of numbers, or the mean of the two middle numbers if n is even. We'll have examples for this, for you to be able to understand better these concepts. So mode, it refers to the number that occurs most frequently in a list of numbers. Is the one I told you already that we don't have a slide for this. So, but hopefully I'll be reminded to give you an example for this verbally, because this concept is easy because it has to do with a number that occurs most frequently in a list of numbers. Okay, that's why it's easy. Even without a slide for this, it's easier to understand. Okay, so since we're learning, we're teaching, so we're not the inventors of these concepts. That's why we are applying deductive reasoning here. No? So if you will look at it so general, so let's apply deductive reasoning. So we consider a specific problem to apply these general concepts. But to be able to apply these general concepts, we must have the formula, which is still general. No? Let's start from the arithmetic mean. So there are three. Let's start with the mean. So the mean is divided. It has two types. There's what you call arithmetic mean, excuse me, and there's another one which is called weighted mean. So arithmetic mean is the one that's most commonly or most familiar with you. No, it's like it's the average. Okay, it's the average. It's the total of the sum of all values in a collection of numbers divided by the number of numbers in a collection. It's calculated by in the following way. So since it's a formula, so there are variables. Okay, these are the data set. So if you look at this small n, remember I told you about population and sample. So if it's small n, this is the formula for the sample mean. If we want a formula for the sample mean, probably this is capital N. I have to distinguish the two because later on you will see capital N. So you might ask, what's the difference? So I'm telling you now. Okay, but again, this arithmetic mean. Maybe the focus here is more on the sample mean. Okay, let's have an example. So since it's not mentioned about population mean, so I expect this is sample mean. So we use the formula. So let's read the problem. Compute the mean of the first 6 odd natural numbers. So you know already what's odd number, what natural number. So odd, so this is the first 6 because 0 is neither, it's an even number, 0, right? So it starts, this is the smallest odd numbers. So we add them divided by 6, so we get 6. So the arithmetic mean is 6. So it says that the center of the data, this data is 6. Okay? Now what's weighted mean? Weighted mean is the type of mean it's not familiar with you, not so familiar with you. And in fact, the formula is really different from the other one. But the principle is the same. Like you add all of them divided by the total. So let's discuss this one by giving examples to understand it better. But let me read this, where the summation of x.w is the sum of the products formed by multiplying each number by its assigned weight. So this one represents the weight. This one is the data, the x here. And summation w is the sum of all the weights. So to get the weighted mean, this is the formula. Now this is very general. Let's apply it. Specific problems. So Weighted mean example. Alex usually eats lunch 7 times a week, but some weeks only gets 1, 2, or 5 lunches. Alex had lunch on probably on 2 weeks. Alex, so probably this is a boy or a girl, maybe Alex Gonzaga. So let's say it's a girl. So maybe Alex Gonzaga is on diet on 2 weeks. So she only eats 1 lunch for the whole week. Just imagine. So she's really on diet. So probably on 2 weeks, she just eats breakfast, parang ganun, breakfast and dinner. There's 1 lunch for the whole week. Like Monday to Sunday, probably she'll just eat 1 lunch. Probably Wednesday. It's 1 for 2 weeks. Then 14 weeks, so 2 lunches, but still so it's still on diet. So 2 lunches each week. Okay, and then 8 weeks, 5 lunches. So probably she doesn't eat on Saturday, Sunday for the lunch, but probably she has breakfast and dinner. Now for the 32 weeks, no more diet. So every day she eats lunch. Okay, the question is, what is the mean number of lunches? So lunches, Alex has each week. So we're getting the average for the lunches. So to solve this problem, you will apply this. So you should be able, right? In solving problem, we have the steps, right? Understand the problem. So in understanding the problem, you should be able to represent what X is, what W is, so that you'll be able to apply this in this formula. The formula is the plan, right? Devise a plan. This is the plan. So you cannot apply the plan or the strategy if you don't understand the problem, because what will you put here? What will you put here if you don't understand the problem? So this problem here presents presented two solutions. The first solution looks like this. But still, you have to identify which is the weeks, which is the X, which is the W. So it's good that the W here is the weeks. So it's good because it starts with W. So the number of weeks is our W. The X is the number of lunches. Okay. So if you will apply the formula, summation of W is this because it's the number of weeks. So if you will go back to the formula, the denominator is the summation of W. So you will add the number of weeks. That's the meaning of summation. So add all of this. Where did you get this? From the problem, remember? 2, 14, 8, 32. Add all of them, then you get the summation, and that will be your denominator here. Now to get this, you apply naman this one. The summation of X times W. The meaning of this, multiply first, then sum it up. No? Meaning to say, you multiply this, 2 times 1, 14 times 2, 8 times 5, 32 times 7, because these are your excess. Then add all the sums. Ayan, there. The sums, 294, divide them, you get this. So this is the weighted mean. Okay, it looks like this if you will represent them. Okay, like the center of the data. Now there's a better way. I don't know if it's better to you, but for me, it's a better way to, what do you call this? Better way to present the solution, which you use a table. It's easier to understand because you have here the representation and the values for these variables. It's easier, it's clearer, right? So this is the W. In fact, you can write here the summation already is this. Then you multiply 2, 14 times 2. You can see it here, right? Instead of the linear one. But this is also acceptable. Usually in statistics, this helps if you put it in a table as a strategy. No? So sigma, you call this sigma. In Greek letter, later on we'll meet other Greek letters. Because usually, though it's not related to this one, maybe probably later I'll mention. So if you add this to 94, if you add this 56, then divide them, you get the same answer as before. Okay, class? So I think that's the mean. Now let's go to median, the second measure of central tendency. So also this one, it depends on the problem or the objective of the user or the researcher. Probably this one is the appropriate to find out or to identify the center of data. Remember, measure of central tendency, we want to identify the center of data. But most of the time, it's the mean, which is the best, right? Most appropriate, but it still depends. Now, what's the median? Median is we get the middle. So it depends. We have two formulas depending whether n is odd or even. If n is odd, so use this formula. So again, it's general. So we apply deductive reasoning. We consider a specific problem, apply this, okay? So when the formula is n, when the median formula, when n is even, this one. Okay, for example, in your data, the sample size, because small n, not capital N, the sample size is 7, so odd. So how do you get the middle? 7 plus 1, 8 divided by 2, 4. So meaning the fourth, if it's arranged from least to greatest, you have to arrange it from least to greatest, the data. The fourth is the median. Okay, the fourth observation, the fourth data value. Now, if n is even, let's say the n is is 8. So how do you get the middle or the median? So you get the 8 observation. I'm sorry. You divide first. 8 divided by 2, 4. And then that 4, you add 1. So you get the 4th and the 5th. But first, you have to arrange it from least to greatest. You get the 4th and the 5th. You add them divided by 2. You'll understand this more or better if you have a specific example. Now, let's apply deductive reasoning. Those formulas we apply here to this specific. No. The Jamaican family drove through 7 states on their summer vacation. Gasoline prices varied from state to state. What is the median gasoline price? Okay, so we have this data collected, and then we arrange this first. So we arrange them. After arranging them, we locate the middle, and that's your median. Since this is odd, even without applying the formula, by just looking at it, we know this is the middle, arranged in ascending order. However, formula is useful, especially if the size is large. If the sample size is large, because you cannot arrange, we have to arrange it. However, it's hard to be, first, second, third, to be doing that. So you have to apply the formula. In applying the formula here, though it's not needed, but since it's smaller, the size is smaller. So 7 plus 1, 8 divided by 2, 4. So the fourth, first, second, third, fourth. Okay, this is the median, not the fourth. The median is 1.84. So the median gasoline price, not the position. The position only pinpoints where the median gasoline price. It's in the fourth, not from the smallest. Okay, now, there, explain in advance, but the explanation is here. Okay, I just explained it in advance. So we use the formula, then we did this. Okay. Now, what if n is even? Let's have a problem when n is even. During the first marking period, Nicole's math quiz scores were 90, 92, 93, 88, 95, 97, 87, and 98. What was the median quiz score? Now, we order first, right? We arrange the data from least to greatest, so before we can identify the median quiz score. Now, since this one is even, so we apply this formula. So 8 divided by 2 is 4. So we identify the fourth, which is 92, and then 4 plus 1, 5th, 93. We add this 2 divided by 2, we get this. So I put this because you might misunderstand, right? Median is 4.5. No, I put an arrow just telling you that this is a position. Our median really is 92.5. It just tells you that it's in here, but you cannot see the 4.5 or even the 92.5, right? It's just here. If it's fourth, you can see. But median or what's this? Median or mean, possible you cannot see in the data. It's not there. Like this one, 92.5, we cannot see, but it's in the middle. Meaning to say, the 4 values, this is one thing for sure, huh? This is one thing for sure. The 4 values are less than 92.5. The other half is greater than. That's why it's median. Even though you don't see 92.5, but it tells you already that the values that are present here, the lower 50% is less than 92.5, which are less than, indeed less than, right? 87, 88, 90, 92 are less than 92.5. The other one, the other half, the upper 50%, which are greater than 92.5, are here, 93, 95, 96, 90, 98. That's why it's not this position, it's the median, it's this one, okay? So now next, this is the next measure. So we're done with the, that's what I'm telling you. They did not discuss about the mode. Remember when we talk about measures of central ascendancy, there are 3 measures, mean, median, and mode. So what is mode? I don't know if I accidentally deleted the slide for that, or it's really intentional that it's not here, so that will be the one to provide. Okay. Anyway, even without slides, it's easy to understand. Like it was defined a while ago, mode is the most frequently occurring data. Most frequently. In this example, there's none because 87 occurred once, and once. So there's no mode. However, if this 2 is 92 and this is 92, the mode is 92. You understand now? 92. If you're asked what's the mode, it's easy. There is no need for formula, right? There's no need for formula. That's why maybe they did not put a slide for that, because we can just say it verbally. So if these 2 are 92, that's the mode. The most frequently occurring data. If this is 92 also, still, that's the mode. 92, 92, 92, that's still the mode. However, just 2 is enough. However, what if you have 92, 92, 95, 95? What's the mode? You will have 2 modes, 92 and 95. So when you're asked what's the mode, you have to mention those 2. Mode quiz score. There will be 2. That's why there's what you call unimodal and bimodal. When you say unimodal, the data is unimodal, you can only see one mode in the data. But if you say bimodal, you can see two. Even trimodal, you even have trimodal. You can see three modes. For example, if this becomes, how many are this? How many do we have here? Is it 9? Or it's, no, it's not 9. Right? It's not 9. 1, 2, 3, 4, 5, 6, 7, 8. There's just 8. So it's hard to divide into 3. We can't have trimodal. I think it's still possible because, for example, I'm sorry. If this is 90, 90, 90, 92, 92, 95, 95. So trimodal. What are the three modes? 90, 92, 95. Okay? So it's the most frequently occurring data value. But in this case, none. Because all of them occur once. Okay? Now let's go to the second measure. The second measure is the measures of dispersion or variability. So disperse, as the word explains, we're not after the center of the data. We're after how the data values are dispersed or vary from each other. So in effect, we're considering all the, in effect, in a way, we want to consider all the data values. Okay? Now, one measure is the range. It refers to the difference between the greatest data value and the least data value in a given set of data values. So without arranging, we can identify easily, but most of the time, or it's better if you arrange them. But this one, since it's just few, no need to arrange. We already know the lowest value is 4, the highest is 9. So just get the difference 6. So this is the range. This is the length of the range 6, meaning to say all these values you can see here. Okay, class? All the range values you can see here, meaning to say the 4 can be found in this range, the 6, the 9, the 3, and the 7 can be found in this range. Okay, class, from 3 to 9, you can find here all this. Now, if this is longer, so that means that's the length of the range. That's why this one is also useful as a measure of dispersion. Now, the second one, now this is the one I told you a while ago, that there is a mention of population and sample later. You will see a sample. So I already mentioned to you the difference between sample and population, right? So you should be able to understand this better. Now, standard deviation, whether it's a sample or population standard deviation, it's a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that the values tend to be close to the mean of the set. So remember the word mean. Remember, mean is a measure of central tendency, but still here, it's related to a measure of dispersion, dispersion such as standard deviation. Well, a high standard deviation indicates that values are spread out over a wider range. Now, you have to mention the mean because the mean is in the formula of the, standard deviation. Now, this is what you call the population standard deviation. Later on, you'll know the symbol for the sample standard deviation. Now, this is a Greek letter called sigma. Usually, when we refer to population, what do you call this? Population parameter. For example, population mean, population median, population mode, and this one, population standard deviation. We use Greek letters for that matter. So we use Greek letters for population parameters. So we have here the population standard deviation, and we also use population mean. Population mean, we use this Greek letter. We call this mu. Later on, you will know another symbol for a mean, which is a sample mean, not mu. So we use their alphabets, not Greek letters. So that's how one way to find out whether the formula has to do with population or sample. Plus this one, capital, the sample size, the population size is capitalized. In a sample size, it's small n. So we already know if that the formula is for the sample, small n. That's a small n already. Okay. So now to understand this formula, we have to apply it in a particular problem. So again, deductive reasoning. No? Okay, don't mind the red. I added them, the red, to be able to find the standard deviation of this. Since it's find the mean of population mean, so we're looking for population standard deviation. Despite that, the data is just few, just 4. Remember, I told you if it's population, usually it's a large data, but sometimes it is also small, like this one. That's why this population is also the sample. There's no need to get a sample because it's just 4. Remember? But still, they applied the population, not the sample. There's no need to use the sample because better to use the population because it's the population that's given. So we use the formulas for the population. Because if you apply the sample, you will, it's not accurate. It's more accurate to apply the population. Okay, we only apply sample if our data are samples. Because we don't have the population. Why should you apply the population formula? But here we're given the population despite its few. So we use the formula for the population standard deviation. This is the formula, but to find the answer, we have to solve for the population mean. And this is we know this formula already. So it's not the weighted mean, it's the arithmetic mean. Because there are no weights for this, like the lunch, no? Because for the lunch example of Alex Gonzaga, if it's Alex, so it's not really Alex Gonzaga. I'm sorry, this is recorded. So I should have not mentioned that name. Anyway, there's a lot of Alex Gonzaga. Okay. So where are we now? So, okay, so we add all of this. So divided by 4, so this is 3. So now once we get the population mean, we subtract it from the data values, each of them. Now 6 minus 3, this one is 3. 2 minus -3, -1. 3 minus 3, 0. 1 minus 3, -2. Why do we have to do that? To apply this formula. Because we have here x1 minus mu. Then we square it. That's why we have this. So 3 times 3, 9. -1 squared, 1. 0 squared, then 4. Then why do we have to add them? Because of this summation. The meaning of this, add all of this. So once we have this, so we have this already, we can substitute. That's why we put 14 here. And then divided by the population size, which is 4, because it's obvious it's 4. And then we get the square root. We don't have square root for 14. It's a rational number. Square root of 4 is 2. Then we approximate because this is a rational number. So that means the population standard deviation of this example, of this data, is 1.87. Okay, class? 1.87. Now, so you notice this one is related to the mean. Because in getting the standard deviation, we use the mean. So that's why standard deviation is the deviation of each value from the mean. That's what we computed. How is it related to the mean? This one, how is it related? How far are this from the mean? That's what we computed. And we summarized that not one by one, by this single value. So in general, though we see here 3, how far from the mean? 3, 1, absolute value. But in general, the average is like 1.87. If you will look at the data, in general, we use specific values in saying that we can say that the data value is 1.87 far from the mean in general. But we get here the specific, right? But we want to generalize. That's why we use the formula. Okay, that's the reason for the formula. Now, if you square this, we get the next measure of what do you call this? The other measure of variability, which we call variance. Square this, we get the population variance. So just square this. If you square this, you get this one, 14/4. Because the square of the square root of 14/4 is 14/4. So that's the answer. Or if you want to simplify it, that's 7/2. If it is population variance that you want. But if it's population standard deviation, the answer is 1.87. Now, what is this variance? Okay, it's explained. Never mind the red again. Let's focus on this. So variance refers to a statistical measurement of the spread, remember? Variation between numbers in a data set. Unlike the measure of central tendency, it's more the center of the data. And to identify the center of the data, we use measures, right? In measure of central tendency. What are these? The mean, median, mode. Now, which one are we going to use among those three? It depends on the problem. Now, for the measures of variability or dispersion, we also have 3: range, standard deviation, and variance. And that's the meaning of this, spread. Okay, that's what we measure. Measurement of the spread between numbers in a data set, not the center of the data. So when we talk of measures of variability or dispersion, that's what we want. How spread the data or the data in that data set, the numbers in that data set. So we have 3 ways to identify. We can use range, we can use standard deviation, we can use the variance. Okay, but usually the best there is standard deviation. For the best, because for the range, we only consider the lowest and the highest. How about the in between? For the variance and standard deviation, yes, we consider all of them, but usually what we use is the standard deviation, not so much about the variance, but we also use them, but not unlike the variation. Now, for the measures of central tendency, the best there is the mean. Why the mean? Because we consider all in getting the mean, right? We consider all values. All values are considered. Whereas the median, we only consider the middle, right? The mode, we only consider the most frequently occurring data. That's why the best for the measures of central tendency is the mean. Now, for the measures of variability, it's the standard deviation. However, the standard deviation is related to the variance. How? As I mentioned, to get the variance, you just have to square this. So there's a 2 here. Once there's a 2 here, it's called variance. If there's none, then it is standard deviation. But how do you differentiate population standard deviation like this from a sample? The use of the symbol. Because once it's a sample standard deviation, it becomes S. That's why I changed this, because it's mentioned here sample variance. So we have to replace this because we use this symbol for the population variance. This is the population variance. Remember, look at this, related. You just remove the square root, diba? If you get the square, you remove the square root, you get the population variance. Okay, now if you want sample, you have to use S. So since it's sample, so I changed this to S2. Okay, so take note of these writings because it's very important. This one. So I also changed this because if we use the sample variance, which is squared, sample standard deviation, which is S, we use the sample mean, not the population mean. So if we use the sample mean, since it's sample, we use the alphabet, the X, not the Greek letter. So that's how you differentiate. That's how you identify whether the formula is for population and sample. And that's very important. Because if you're given a population data, what will you use sample formula? You will get a wrong interpretation. That's why I told you it's important. So now I know this is a sample. This is for the sample because small n. And this is capital. The reason why this is n-1, it has to do with the concept of bias or unbiased estimator, but we will not tackle that here. But the purpose is to make it unbiased according to the statisticians. Okay, so if there are mathematicians, there are also statisticians. It's better if you make this n-1 rather than n because of the unbiased estimator property. So make it n-1. Okay, I think in the problem this is what we will use. Okay, so let's apply this sample variance. So again, can you see the difference between variance? Whether it's population or what do you call this sample, you already know. To get the sample, the variance in general, whether it's this variance population or this sample variance, it is the square of the standard deviation. Right? Square this, you get variance. Okay. Square this, you get variance. I'm sorry. You still get variance. However, this is population. This is for the sample. I think the next example, that's why I put here sample, is calculate the sample variance. So we use the formula for the sample. Okay, not for the population. Unlike the other one, we use because we're after the population, no? Okay, now let's proceed with the example. Okay, this is the example. So we use the sample mean. So whether it's sample mean or population mean, the same principle. Add all of them divided by 2. Anyway, this is not weighted mean, right? It's just arithmetic mean. So just add all of them, then we get this. 33 divided by 6.6. So similarly, since this is like variance or standard deviation, or in other words, it's a measure of dispersion, so we want to relate it to the mean. Each of this, we want to get to relate to the mean. So we subtract in relating. So we subtract them. That's what we have here. So 2 minus 6.6, negative 4.6. 7 minus 6.6, 0.4, and so on and so forth. Now to get this, to apply it in this formula, you have to square this. Square, we get this, square, and so on. Now, since there's a summation, you have to add all of this. We get the sum. Then we substitute. That's all we have to do. And then n minus 1, since n is 5, 5 minus 1, 4. Then divide, you get the sample variance. So this is the sample variance of this data. Now, since sample variance is related to standard deviation, so if you want to get the sample standard deviation, just get the square root, diba? Square root. Square root of 17.3 is equal to S. Okay, class? Okay. So now, what's the difference? I've been telling you the difference, so let's just put it in here. Let's read it. So variance is the average square deviations, as I mentioned, from the mean, while standard deviation is the square root of this number. So both measures reflect variability in a distribution, but their units differ, of course, because variance, you square the standard deviation. So if the standard unit of standard deviation is minute, once you square it, it will become larger. It will become meter squared, right? Similarly for the minutes, right? If you square 2, of course, 4 is bigger than 2. Something like that. Okay, now we're on the third part of the lesson, which is called the measure of relative position or location. So again, as I mentioned at the beginning, the keywords here are percentiles, quartiles. And then we will summarize the 3 measures using the box and whisker plots. Okay, but it's more related to this measure of relative position. Now, what is a percentile? As the word implies, percent, diba? In terms of 100. That's why you see here 100. And you will, in the example, you will see percent. Because when you see percent, it has to do with 100. Quartile, it has to do with quarter. So into 4. Or anyway, later, you'll understand that better with examples. So a percentile is a term used in statistics to express how a score compares to other scores in the same set. A value called X called P, percentile of a data set provided P% of the data values are less than X. Given a set of data and a data value X, this is the formula. You'll understand this better with the example. Okay, this is the example. You are the 4th tallest person in a group. Never mind this muna. In a group of 20. So 80% of the people are shorter than you. So this is you. So say your height is 1.85. So meaning to say, this, since there's 20, this 16 has height less than 1.85, less than. However, you and this 3 have a height equal or greater than 1.85. In fact, you are 1.85. It's possible the others also here is 1.85. But as the drawing shows, this is tall. He or she is taller than you. So how to get the 80%? Because 16 are lower than you and 20 are the total it mentions here, the total number of data values, that the number of data values less than X. So meaning X is 1.85. So less than that, how many? 16. So 16 divided by 20.8 times 100. That's why we get here 80%. The 80% is important because this can change. So for example, in a group of 100, so how many are, for example, 1.85 is the 18th percentile, 80th percentile of the 100. So how many are less than 1.85? How many people are less than 1.85? If it's 100, since there's 80%, 80% of 100 is 80. So you all know already that 80 are less than 1.85. So that's the meaning of this one. That's why it's in percent, because the number can change. The sample size or the population size can change. But once you know this 1.85, you're given this data, like the one we mentioned a while ago before this class. No? The example of the data, the summary data, right? Like the mean and the average. So once we have this, we don't show the computation. We already know now once you're given 1.85 is the 18% height in that group, you just have to know what's the sample or the population size. If we know it's 100, so we already know that 80 of these people has height lower than 1.85. The 20 has height greater than or less than 1.85, including you. Now, if you make it 200, it will change again. You get the 80% of 200, that's 160. So that means the 160 have height lower than 1.85. And since it's 200 minus 160, the 40 have height greater than or equal to 1.85. That's why it's important in percent, because this one can change. So that's in percent, 100. Now, quartile is, since it's quartile, we divide the data into four. Okay, that's why we have Q1, Q2, Q3. Now, Q2 is related to the median because you divide the data into two. Now, if you divided the data into two, that means Q1 is the median of the data values less than Q2. Then Q3 is the median of the data values greater than Q2. Now, you understand it's better in specific examples. So all you need to understand for now is that quartiles are the values that divide a list of numbers into quarters into four. Okay, box and whisker plot will show these three measures. We will illustrate using this box and whisker plot. So it's a display used to show the quartiles and the maximum minimum values of a data set. Though it's only mentioned quartiles, but we already know that Q2 is median. So there is a measure of what? Measure of central tendencies, because we all know that median is a measure of central tendency. However, quartiles is a measure of what? Measure of relative position. Where is the measure of dispersion? It's this one, the maximum and minimum. Remember, to get the range, we get the difference of these two, right? So somehow in a box whisker plot, we can see these three measures of descriptive statistics, but it's not really that accurate, because as I told you, the best measure of central tendency is the mean. The best measure of dispersion is the standard deviation. Okay, but for the relative position, there's none really. Which one? It really depends on the objective. So now, okay, how do you get the quartiles? So given this, so you're given how many? 2, 4, 6, 7. So if it's odd, it's like the formula for getting the median class. So how do you get the median again? So if it's odd, n plus 1 divided by 2. Since this is 7, so 7 plus 1, 8 divided by 2, 4. So where's the fourth? This one. So this is the middle. Actually, without applying the formula, we already know this is the median. This is the Q2. That's another term, middle quartile Q2. Now, how do you get this one? As I mentioned a while ago, the Q1 is the median of the values less than the Q2. That's the meaning of this one. The meaning of this one. Q1 is the median of the data values less than Q2. Q3 is the median of the data values greater than Q2. So the meaning of those two is this. Since these are the values less than Q2, the median of this is 4, which is Q1. But if you will only consider this is median. But since you're considering the whole data, in relation to the whole data, we call this the Q1. Q1 is equal to 4. Now, for this whole data, Q2 is 5. Now, what's the middle of those values greater than Q2? So obviously, it's 7, right? The middle. So if you consider the whole data, that's Q3. That's why we have these values. Q1 is 4, Q2 is 5, which is also called the median. Q3 is 7. Okay. What if we have even, not odd? So we apply the similar formula when we discuss the median for even. So how many are this? 2, 4, 6, 10. So 10 divided by 2 is 5 plus 1, 6. So you get the fifth and the sixth. So this is the fifth and the sixth. You add them divided by 2. So you get the median 5.5. Now, as explained a while ago, how do you get Q1? It's the median of those values less than 5.5. Since these are the values, what's the middle of this 5? 3, obviously. So that's your Q1. So what is Q3? All the values greater than 5.5. What's the median? 7. So that's your Q3. So here are the answers here. Q1 is 3, Q2 is 5.5, Q3 is 7. Now we're ready to represent these numbers in terms of box and whisker plot. So let's explain in general. So upper extreme, meaning to say this is the highest value, probably 22, something like that. And then this lower extreme is the smallest, so probably 2. That's an example only. So lower extreme is the smallest value in a given data set. Upper extreme is the highest value in a given data set. The median value is the middle number in the data set, which is actually Q2. This one, Q2. Lower quartile, below that value, the lower 25% data are contained, meaning this. This is the Q1, right? Q1, Q2, Q3. The upper quartile above that value, the upper 25% of the data are contained. The whiskers are this, the lines. There's still values here. Possible you still have values here, class. But among the values, this is the highest, this is the smallest. And this is the Q1, the Q2, the Q3. Let's apply So you're given this problem. So let's draw the box and whisker plot. So you're given here 15. So first you have to arrange them. So arrange them, and then what do you do? Identify the median, the middle. Since there's 15, 15 plus 1 is what? 15 plus 1 is 16 divided by 2, 8. So the 8. So you count here. So this is the 8. This is the median. This is the Q2. Now, how do you get the Q1? So there's 7 here. There's 7 here. So what's the middle here? So of course, this is your Q1 na. The middle is 70. So what's the middle here to get the Q3? 88, obviously. Now we have these numbers, and the lowest is 54. The highest is 95. Now we have these 5 numbers already. So we're ready to draw the box and whisker na. We're ready to draw. I already mentioned this in advance, right? But it's all written here na. It's all written. Now let's plot this. So we get this box and whisker. Okay, where's the highest? The highest is this, which is 95. What's the lowest? 54. Which is this, 54. Where's the median? This one, Q2, which is 80, right? So it says here 80. Where is the 70 and 88? That's the Q1, Q3 respectively. So this is the 70 Q1, this is the 88 Q3. So see, so we were able to represent these measures using a box and whisker plot. Though it's not the best representative of these measures, however, why it's not the best? Because we use here median as the measure of central tendency. Then we use the Q1, the Q3, or even this Q2 as the measures of relative location. And then for the measures of dispersion, we use the range. We have the lowest and the highest, but it's not the best because, as we mentioned, we did not use here the best measure for each, right? Because the best measure of central tendency is the mean. The best measure of, most of the time, the best measure of dispersion is the standard deviation. For the relative position, well, it doesn't matter. Later on, probably, I don't know if we'll be able to discuss that next week. We will use these two, the mean and the standard deviation, if we tackle that topic about normal distribution, which has to do with the score. However, since we did not discuss this score, I don't think we'll be able to apply that. No, what I'm saying is there's the best. No, and this best, we usually use it in inferential statistics, but this one is descriptive statistics, as I've mentioned. I think this is the end. This ends week 8 class.